section 5.5 and 5.3, we were writing equations of parallel and perpendicular lines from point-slope form. If you watch the preview video, you can see where we came up with the formula. But to start, we should have memorized that point-slope formula is y minus y1 equals n parentheses x minus x1. In the example that I have ready for you here, we're going to write the equation of the line that's parallel to this old line. So in other words, we know that parallel lines are going to have the same slope, so the new m of our new line will have the same slope of 1/2. The rest of it becomes garbage now, because remember that was the old line. So for example, if it's going through 2 and it goes up 1 over 2, the old line would look something like this. We want to find the line that's parallel but goes through the point 1, 3. So my x is going to be 1 and my y is going to be 3. Again, that is my new point, so it's my new x and my new y. Plugging it in, we get y minus y1. That's what my 3 is. Don't forget to bring down everything else, including all those signs. So the new m, 1/2, x minus x1. So we can distribute in if we want to get this in a different form. So for example, this would help me get it into slope-intercept form. Again, you could do that on a calculator or in your head. That's 2.5. And then if I wanted to get it into standard form, remember I could move this back over. And for many books, we do not want to have a negative a nor a fraction for a, b, or c. So multiplying through by a -2 would take care of that. So these guys would cancel, leaving me with an x. When I distribute to here, I would get -2y. And when I distribute to the other side, or when I multiply to the other side, I should say, I get -5. So that would be in standard form. So point slope is pretty helpful. We can just input the new m, the new x, and the new y. Notice we didn't really exactly find the new b, but if I went to slope-intercept form, I could find the new b. And so notice that the new b was at 2.5, and so if it's parallel, it's going to have the same slope. And if it's going to go through the point 1, 3, you'll see why they don't have to have the same b. Now, the only other difference that you'll see in this section is what would happen if I said perpendicular to blah, blah, blah. So how about some function like 6x minus 2? And again, I chose to squeeze in function notation here. You could also see it just in regular slope-intercept form. So remember, if this is the old equation, then the old slope would be 6. So the new slope would have to be the opposite and the reciprocal. And then you'd plug it in a very similar fashion. They'd have to give you an x and a y, and you'd be off and rolling. Good luck on this section.